there! What comes into your mind when I mention ferrofluid? No, not the chocolate brand, but rather something to do with nanoscale ferromagnetic particles. Fancy, huh? What exactly is ferrofluid? Ferrofluid is a liquid that is attracted to the magnetic poles made of nanoscale ferromagnetic particles suspended in a carrier fluid. Ferromagnetism can be found in metals such as iron and is the property of materials being attracted to magnets. The atomic moments of ferromagnetic material exhibit strong interactions as a result of electron exchange between atoms. When the material is placed in a magnetic field, the atomic moments align in parallel and anti-parallel directions. Now, although you can buy your own ferrofluid, not everyone can afford it, so let's make one ourselves. Now, there's only two materials involved: iron oxide or iron powder, and matic motor oil, because viscosity matters here. Viscosity matters because we need to use a suitable carrier fluid. Here, I use water instead of motor oil and it just does not work. It wouldn't mix, and although you can see pretty cool magnetic interactions, it's not the result we are looking for. Now I'm pouring 20 grams of iron powder, although I did intend to use iron oxide initially, but it got lost during transit. And an equal amount of matic motor oil, so also 20 grams. And now all we have to do is mix them together and just be a little bit patient. Obviously this is not enough iron powder, so I added another 20 grams. There are three things involved in a ferrofluid: a magnetite, or iron powder, which causes all of the magnetic properties, a carrier fluid, and a surfactant, because in the presence of surfactants, the particles can be suspended in solution rather than clumped together. Surfactants are added to adhere, surround the small particles, overcome their attractive tendencies, and create a net repulsion between them. Structure created will actually create electrostatic interparticle repulsion that can overcome the van der Waals forces. In this case, our motor oil acts as both a carrier fluid and surfactant, since it is typically used to create thin film on the metallic part of an engine. When a magnet is placed near the ferrofluid, you can see spikes. The spikes arise from the tendency of particles to line up along the magnetic field lines to actually lower their energy. This is because the particle we used, or iron powder, is a magnetic material which contains unpaired electrons, and the electrons can provide contributions to magnetism through their spin angular momentum and their orbital angular momentum. Now you might be wondering, why don't the spikes stay? Well, in the presence of a magnet, the particles will attempt to orient themselves in the magnetic field, but their mobility is limited by the fluid. This causes the spikes to form, but in the absence of a magnetic field, the particles quickly return to a random orientation relative to one another and the spikes disappear. That is all for the video, and I hope you learned a lot about ferrofluid and ferromagnetism.